Hey guys, we're going to talk about solving equations that have these radicals in them. And what I want you thinking about is look at that second step and what in that second step clears out the radical of the exponent, because an equation is solved, right, if it says x equals at the bottom. And so that means we don't have an exponent, we don't have a radical, we just have x as a number. And so as you're looking at what process we're using, be watching for why does that number get to go away? Because I think that will be something that will be good to recognize and to use to your advantage. So we're going to do two examples. The second one gets a little bit weird, but we'll survive. It's not a bad weird. It's just a unique situation that comes up. So here's our first example. First example is pretty straightforward, pretty fun, pretty much awesome. So I've got the cubed root of x squared plus 4 minus 2 equals 0. Okay? So immediately, right away, if we can, we are going to isolate the radical. So if you don't know what isolate means, it means get alone. And so our goal is to say, this radical right here, if I can, I want it to be the only part of the equation on its side. And so what that means is this minus 2 needs to be canceled with a plus 2. When I do that, I get that radical alone, which is great because now I can really try and tackle it. And what I do to tackle it is I raise both sides of the equation to the same exponent. In this case, the exponent I'm going to choose is tied to the index that I have. The index I have is a 3, and so I am going to raise both sides to the third. And then the index of 3 will get to cancel the radical of 3, which is super helpful, because then I get x squared plus 4 equals 8. The reason it equals 8 is because 2 to the third is 8. Okay? So then the third step, solve your new equation. This one's got a quadratic, but it's got kind of a nice quadratic. So instead of needing to factor it, I'm just going to work with the quadratic the way I would a regular x. So I'm going to subtract 4 from both sides. And then I'm going to say, hey guys, look at this. X squared equals 4. I can take the square root of that. Don't need the quadratic formula. Don't need to complete the square. I just get to live dangerously with square roots. And I get x equals plus or minus 2. Okay? Then I'm going to go back and I'm just going to do a quick little check of my work here. If I put in positive 2 squared plus 4, that gives me an okay number. That gives me the cubed root of 8, which is totally fine. If I put in negative 2 squared plus 4, again, get the cubed root of 8, which is totally fine. And so both of my solutions get the Visto seal of approval. Okay? But don't worry too much about this stuff in the purple, but it's just something to have in the back of our mind that our answers should probably be double checked. Okay? Let's finish writing down that example. Pause, go back, rewatch it, do what you need to do, look at the key steps, embrace all the awesomeness that's going on there. And then we are going to take a different look at a second example. Okay, so the second example is good. It's got a wrinkle, which I love. I love a good wrinkle. It's actually got 2 wrinkles, which is even better. But here's what we're gonna take a look at. Now I've got 3x plus 4 raised to the 1/2 equals 6x plus 9 raised to the 1/2. Okay? good stuff happening here. Fun things, crazy things, mathematically things. But as I look at this, in this particular problem, step 1 before was isolate the radical. And this problem doesn't really work to isolate the radical. We can't get the radical alone because there's radicals everywhere in this problem. And you're like, Visto, I don't see any radicals. Well, those stuff with the parentheses and the fraction, those are our radicals. So since it doesn't really work, we're going to just have to get rolling with our exponent. So in this problem, we've got this right here raised to the 1/2. Notice the 3 is not part of it. Ignore the 3. And we've got this right here raised to the 1/2. And since things raised to the 1/2 are like square roots, we are going to start things off by squaring each side of this problem. Okay? So following the exponent rules, as we square each side, 3 squared is 9. And the stuff in the parentheses, when that gets squared, it just gets to come out of the parentheses and be happy. So we did step 2, which was raise both sides to the same exponent. In this case, it was 2. Last time it was 3. Next time it might be 75. Just kidding, it probably won't, but you get what I mean. Hopefully. So then we finish it off. We're going to solve it like normal. So right away, I see the distributive property in action. So I got 9x plus 36 equals 6x plus 9. So I can solve that. So I'm going to get all my x's on one side. And then while I'm doing that, I'm going to clear that 36 away from the x side. And I'm going to end up with 3x equals negative 27, and x will equal negative 9. Okay. Now, I told you this one had a wrinkle. I said it was fun. And then you guys said that my version of fun is different than yours. And I said that's okay. But here's what I mean. Immediately, remember I talked up above that it is important to go back and try some stuff out. So if I take negative 9 and I just look at that very first set of parentheses right here, let me try something. I'm going to put negative 9 in there. And I get negative 9 plus 4 raised to the 1/2. Don't forget about the 1/2. It's not enough just to put it in the parentheses. We actually have to kind of look at what we're doing here. Well, negative 9 plus 4. If I owed you $5 and I paid you if I owed you $9 and I only paid you 4 of them back, we're not square. You're probably still pretty mad at me because I still owe you $5. It's hard. Well, it's not in this chapter, in this unit, we're not going to deal with the square root of a negative number. Okay? We can deal with cubed roots of negative numbers, but we're not going to deal with the square root of a negative number. So this answer does not get the Visto seal of approval, and actually, it gets that same name that we had last chapter, which was extraneous solution. Please don't worry too much about that, but I just wanted to show you how some answers are going to cause problems. So we may want to make sure that we go back and check our solution. Just test run it in your radical or in your fraction. But just be mindful of, I'm not going to give you a problem that this is going to be a big deal breaker for you, but just please promise me you'll have it in the back of your mind. Otherwise, I know you can do this. You got this. Ready, go.